All right, for this part is basically the same. We're going to try and create the average. So the average or S bar, whichever method you like better. So it's going to be 2 plus, let's use this guy, 2 plus 1.187, and that's going to be divided by 2. All right, so 1.593. Okay, so now 1.187 plus 0.7 divided by 2, 0.9435. Then we have 0.7 plus 0.413 divided by 2 is 55.6. Then we have 0.413 plus 0.226 enter divided by 2 is 31.9. Okay, then we have 0.226 plus 0.101 enter divided by 2 equals, this is 0.1635. Then we have 0.101 plus 0.033, and that is divided by 2. So we have 0.067, and then we have so this one is 0.067, yeah. Then we have 0.033 plus 0.007 divided by 2. So this is going to be 0.02, and then we have 0.07 plus 0 divided by 2. 0.007 divided by 2. Okay, 0.0035. All right, so here we have to do the same thing as we did before. Here we basically have to add up these numbers so that we can have our delta, or basically we have our delta x, or average spacing or displacement. The next step is to multiply this value. We're going to do the delta x. It's going to be multiply this value times the delta t. So s average times or delta t, which this guy is 0.25. Okay, so for that we use the calculator and we use the delta t as 0.25, so 1.593 times 0.25, and that is 0.3925. Alright, the next one is 0.9435, 0.9435 times 0.25 equals 0.235. The next one is 0.556 times 0.25, 0.139. This one is 0.319 times 0.25 equals 0.079. 0.1635 times 0.25, 0.04. Next one is 0.067 times 0.25, 0.016. Next one is 0.02 times 0.25, 0.005, and 0.0035 times 0.25 equals 0.0008. Very close to 0. Okay, so now that we have delta x, we can find the distance that they're asking for, because the question that we're trying to answer is distance traveled by the rod. Okay, next we want to find the actual distance. So this will be x, and all this is in meters. So the average, the delta x, and the actual distance, which is what they're trying to tell us to find. So for that, we're going to continue our table where we're going to use the values from delta x to find our displacement. Okay. So we have two options, and really they're not telling us where to start. So if this was a problem that I asked you to solve, I would accept two answers. Look, that they're asking for the distance traveled. So we have the option of, say, the rod, it's a piston, which mechanism that is making it move up and down. And then the option is we take this as 0.0 and this as x maximum, or if this is confusing, let's do it like this. So this is the piston, the mechanism that's making it move. All right, and it's moving left and right. All right, this is the x direction. So if this is 0, and this is whatever over here, wherever is completely stretched, is x maximum, or this is the initial x, this is the second option, x initial, and this is x final. But x final is going to be 0. So whichever option you go for, it will count. The simplest one is to start from x being 0 when the acceleration point is maximum. So when x is 0, when time is 0, that will be the simplest. Because in this case, we only have to take the delta x as our reference point. So we'll take the same way. We'll create a table based on these values like we did before. So first we start from rest, as we said that we would. Then our next step is x, there's no, from 0, the next difference is delta x. So the next one is pretty simple. It's 0 plus 0.392. Then we're gonna need the calculator again. All right, then we need 0.392 plus 0.235, and that is 0.627. Next one is that plus 0.139, which is 0.766. That plus 0.079, which is 0.845. That plus 0.04, which is 0.885. Then that plus 0.016, which is 0.901, plus 0.005, which is 0.906, and plus 0.0008, which is 0.9068. All right, so if I did that correctly, we would have a graph such as time here, x here in meters, time in seconds, and then is 0. So we have 0.25, 0.5, 75, 1, 125, 0.5, 2. Okay, so 0.25, 0.5, 75, 1. All right, so we have that at 0 is 0, so that's good. Then at 0.25 is 39. At 0.5 is 0.62. At 0.75, 0.76. At next one is 0.84. So it's like this, something like this. It shouldn't go above 1, so I need to fix that. Let's see. We got velocity, and where's our next one here? So we got the velocity curve, which we already computed, but now we need our distance, which is this one. All right, and yeah, something like that. Cool. So if you notice, this is our plot that we just computed, and what it's saying is that in 2 seconds, where's my graph for acceleration? In 2 seconds, the acceleration goes from -4 meters per second squared to 0 with this nonlinear curve. The speed is 2 meters per second to 0, and traveled was a huge distance because traveled almost 1 meter, which is almost about 3 feet. So almost 1 meter in 2 seconds. So it's a pretty long displacement. An engine will be a few centimeters, less than 200 centimeters. But this piston is really a huge piston. All right, so this is how you do the problem with average acceleration, average velocity, and average displacement.